Hey guys, I want to talk to you about how to add or subtract rational expressions. The idea is very similar to adding and subtracting fractions. The idea is that we need common denominators in order to be able to add or subtract. So adding or subtracting rational expressions is, in my opinion, the harder of the operations. Multiplying and dividing is a little bit nicer because all you have to do is factor and then maybe cross simplify. But let me just show you real quick how to subtract two expressions that already have common denominators. Like say I have something like 3x plus 1 over, say, x plus 2 minus, say, x plus 3 over x plus 2. Here's a rational, sorry, I don't know why I wrote parentheses on that first one, but here's a rational expression minus another rational expression. The idea is that if I want to subtract these two, they already have common denominators, so I know that the denominator will be x plus 2, but then if I want to actually do the subtraction, then I should combine the two fractions. I recommend you do this first, 3x plus 1 minus x plus 3, so that you can see that this negative actually belongs to each of them. You could even just jump straight to writing it as 3x plus 1 minus x minus 3 over x plus 2. Point is that after you combine like terms, you're left with 2x minus 2 over x plus 2. And don't forget that anytime you add or subtract fractions, you do have to see if you can simplify. To simplify, you should factor the numerator and denominator and see if anything cross simplifies or anything simplifies top to bottom. So in this case, nothing cancels out. I could leave my answer as 2x minus 2 over x plus 2, or maybe even as 2 times x minus 1 over x plus 2. I prefer the second one because it's already in factored form. That reminds me that I tried to simplify, no problem. But the truth is, I could probably jump straight to the answer, at least to this answer right away. 3x minus x gives me 2x. 1 minus 3 is negative 2. And the denominator is x plus 2, so it stays x plus 2. This middle step, though, I think will help if you write it out so that you don't forget to distribute the negative, because usually the biggest mistake happens right here with the subtraction. So I'm going to show you first how to find the LCD, and then I'll show you a few of what I think are the harder problems for adding and subtracting rational expressions. So let's just go through it. All right, so the least common denominator is the product of the unique factors of each of the denominators with the highest power from each individual factor. What do I mean? I mean, like if I had, say, 5x over x plus 1, and I had 3x over x plus 2. Just looking at their denominators, they can't be factored any further, so maybe I'll put them in parentheses and say this is its own factor, this is its own factor. So the LCD is x plus 1 and x plus 2. It's the product of the unique factors of the denominators, meaning you get to go through and grab one of each of them. In this case, there's an x plus 1, there's an x plus 2, fine. But let me say, what if I had, 3x plus 1 over x minus 2, and I'm sorry, let's do x minus 2 times x plus 3. And then say over here I had x over x minus 2, x minus 4. And what's the LCD in this case? The least common denominator, again, is the product of the unique factors. So you just go through and grab one of everything. X minus 2, x plus 3, x minus 4. I'm taking the product of the unique factors. There's an x minus 2, there's an x plus 3. I don't necessarily take this x minus 2 because I already took one. So it's represented here, but it doesn't actually show up as a unique factor in the x minus 2 because I already have one of the x minus 2s. So you're really just grabbing one of everything. You just have to go through and go back and ask yourself, am I taking the one with the highest power? So since you only get to grab one of everything, you should really take the one with the highest power. In this case, none of them had higher power, so there haven't been any powers yet. But if I gave you, say, something like, let's just take 5x squared minus 2 over x plus 1 to the third x minus 1. And 5 over x plus 3, x plus 1, then in this case, the LCD is not only x plus 1 times x minus 1 times x plus 3, because these are the unique factors. There's an x plus 1, an x minus 1, and x plus 3. But since there's two x plus 1s, I want to make sure I grab the one with the highest power. So the highest power is 3. So on the x plus 1s, I take the x plus 1 to the third, then the x plus 3, then the x minus 1. And maybe I said that backwards, but it doesn't matter the order, right? Multiplication is commutative, so you can put any factor that you want first in terms of the LCD. If it's not actually factored, then you have to do some factoring on your own. Now, the problems on the pre-problem of the day, they say, okay, find the LCD of something like 3 over x and 2 over x minus 9. Again, there's some similarities. Notice in this case, they both have x's, but this side doesn't factor. It's its own factor. This side doesn't factor. It's its own factor. So the LCD here is really just x times x minus 9. There are no common factors. I just grab one of everything. I take the x. I take the x minus 9. Or if I had, say, 12 over x plus 8 and 11 over x minus 8. Ooh, now these ones look close. X plus 8, x minus 8, they look very similar, but I can't actually make an x plus 8 and x minus 8. I can't take an x minus 8 and make it an x plus 8. These don't factor, so x plus 8 is its own factor, x minus 8 is its own factor. The LCD is always the product of the unique factors, so I have to bring an x plus 8, and I have to bring an x minus 8. That's the best I could do. So you're grabbing one of everything. Maybe, in the worst case scenario, I make it something like y, well, let me see here. All right, so actually let's say that maybe instead of starting with what I was thinking, let's actually do 2 over x squared plus 12x plus 36 plus 9, not plus, but just find the LCD between 2 over x squared plus 12x plus 36 and 9 over x squared minus 36. Notice in this case the denominators aren't factorable, or they are factorable, they're not factored. So if I factor x squared plus 12x plus 36, I'm asking myself what two numbers multiply to 36 and add to 12. It's 6 and 6. So it factors to be x plus 6, x plus 6, or what I should do is write it as x plus 6 squared. And then if I take the x squared minus 36, I see that factors, that's a difference of squares, it's x plus 6, x minus 6. So in this case, it's a little bit different, because now not only did they factor, but what's the LCD? The least common denominator between the two is x plus 6 squared, x minus 6. I take the unique factors, x plus 6, x minus 6, and I say which one has the highest power? Well, x plus 6 squared has the highest power between the x plus 6's, so I take the x plus 6 squared. This guy doesn't get brought along. So it really just ends up to be x plus 6 squared times x plus 6. X minus 6. All right, but what if I actually want to add, though? Let me do that one as an entire problem. Say I want to add 2 over x squared plus 12x plus 36, and I want to add that to 9 over x squared minus 36. Well, then since I've already factored the denominators, I can use that. This factors to be x plus 6 squared. This factors to be x plus 6, x minus 6. So the question is, how do I actually subtract them, or how do I actually add them in this case? Well, you need to get them to both have the same denominators, right? I have the 2 over here, I have the 9 over here, but I want them to be with that common denominator, that LCD that we just found, x plus 6 squared, x minus 6. Okay, I can't just put those common denominators underneath. No way, I've changed the entire problem. Instead, what I should do is ask myself, what's missing and then multiply that to the top and bottom. Meaning this. Look at this fraction over here. 2 over x plus 6 squared on the left has an x plus 6 squared and an x minus 6. I'm missing this x minus 6 here. So to make these two look the same, I should really just multiply the entire denominator by x minus 6. That makes this denominator look like this denominator. I can't just change the bottom though. Whatever I do to the bottom, I also have to do to the top. I should multiply the top by x minus 6 as well, so that I'm left with 2x minus 12 over x plus 6 squared x minus 6. Same thing here. I have x plus 6, I have an x minus 6, but I don't have an x plus 6 squared. This square is missing. So how do I get an x plus 6 squared? I multiply by another x plus 6 on the right. This isn't fraction busting. I can't just fraction bust. It's not an equation. I have to multiply whatever I multiply to the bottom also to the top. So in this case, it becomes 9x plus 54. So then what you end up with is, when you add 2x plus 9x gives me 11x. Negative 12 plus 54 is 42, positive 42, all over x plus 6 squared times x minus 6. Again, we factored the denominators and found the LCD, but we wanted to know, how do I convert into this new LCD? So 2 over x squared plus, 2 over x plus 6 squared is the same as 2x minus 12 over x plus 6 squared times x minus 6, because if the 2's factored out, the x minus 6's would cancel. You'd end up right back here. The point was, though, to get common denominators so that you can add them. All right, let's try one more. All right, let's say we're asked to add 4 over x squared plus 2x plus 1 and 7 over x squared minus 1. Again, very similar to before. This one on the left factors to be a difference of squares. The two numbers that multiply to 1 and add up to 2. I'm sorry, it's not a different square. It's a perfect square trinomial. So the two numbers that multiply to 1 and add to 2 are x plus 1, x plus 1. It factors to be x plus 1 squared. On the right, I have 7 over x squared minus 1, but x squared minus 1, that's a difference of squares. It factors to be x minus 1, x plus 1. So then I see that the LCD is x plus 1 squared times x minus 1. It's the product of the unique factors with the highest power on the x plus 1. Since I only get to take 1, I would take the x plus 1 squared. All right, but as long as I know that's the LCD, then I'm in good shape. I can make two fractions with that same denominator. And then the idea is that to get 4 over x plus 1 squared to have LCD x plus 1 squared x minus 1, I got to multiply top and bottom by x minus 1. I multiply by x minus 1 here, I multiply by x minus 1 here, and I'm left with 4x minus 4 over x plus 1 squared times x minus 1. Notice that's the same fraction. I haven't changed anything. If you factor out the 4 and cancel out the x minus 1, you would go back one step. Now, it's not a good idea to do that, but you could check that you did it correctly. Then for the same thing on the left, I have an x minus 1, I have x plus 1, but I want an x plus 1 squared, so I should multiply times another x plus 1. And then in this case, that gives me 7x plus 7, so I can add those two together. I don't know why I made the subtraction. Sorry about that. 4x plus 7x gives me 11x again, but then negative 4 plus 7 gives me positive 3. So like I said, you don't really need that intermittent step, especially if it's addition. If it's subtraction, though, make sure you do distribute the negative through to each of them. At the end, you technically should try to factor the numerator and see if anything simplifies, but 11x plus 3 over, well, that doesn't factor, and so I just leave it as 11x plus 3 over x squared, x plus 1 squared times x minus 1. All right, so try it out. Let me know if you have any questions.